Assalamu alaikum. Welcome to the second tutorial of this course, Material Science for the Spring 2023 semester. The second tutorial, as you all know, is the pre-final exam practice session. So we will be solving a few things which can help you in the preparation for finals. Usually I include the solution of the midterm in this tutorial also, but because you already know the decision about the chapters that will be included in the final exam, and that does not include, the final does not include any of the chapters which were covered in the midterm. So this time this tutorial will therefore include only the solutions of quiz 3 and quiz 4. If you have any other questions that you need to ask me, you can contact me, you can come to my office and so on. We will start with quiz 3, and as I mentioned earlier, whenever there are two sections, so then you are more lucky that you have questions from both the sections, so you have a larger number of practice problems. The first question always is the multiple choice and the true false. So this question, solidification of a molten metal happens at dash, right? Melting point, freezing point, equilibrium point. So obviously the correct answer is melting point or freezing point, because they are the same thing. Remember, when we are heating the material, melting point is the temperature where it starts to melt. When we are cooling the material, melting point or freezing point is the temperature where it starts to solidify. So the same temperature is called melting point or freezing point. Therefore this MP or FP is the correct answer. Next question, when two elements are completely soluble in each other in liquid and solid state, we have a dash alloy system: isomorphous, binary, multimorphous, tertiary, right? So tertiary, multimorphous is not definitely there. Binary could be anything which has two materials, but that is not mentioned here. The main thing is that they are 100% soluble in each other. So then it is an isomorphous system. Isomorphous, right? That it has, when they are 100% soluble in each other, then they will create only one solid phase in the end. So this is an isomorphous alloy system. Next question, the temperature and composition where liquid metal suddenly changes into two solids is this. Remember, a temperature and composition where liquid metal suddenly changes, right? So it is a triple point, it is a eutectic point, it is a double point. It is definitely not a double point, so that is out. It is a eutectic point, that is the definition of eutectic, that liquid suddenly changes into two solids. But also it is a triple point. This is very important. It is a triple point because there was one liquid on one side and two solids on the other side. So three stages, one liquid and two solids coexist at that point. So it is a triple point, right? So if you click eutectic point, you are correct, but you are not totally correct. If you click triple point and eutectic point, then you will be totally correct in this question. Next one, an alloy of eutectic composition freezes at a lower temperature than all other compositions. Just think on it, or look at a diagram. Look at any phase diagram which contains a eutectic point. So to the left you will have liquid, then solid plus liquid, then solid. To the right of this you will again have liquid, solid plus liquid, and then solid, right? So if this is not the point, if you are not at the eutectic point, then to the left of this or to the right of this on the phase diagram, it will start to solidify at a higher temperature than this. But here at eutectic, all liquid suddenly changes into two solids, right? So this statement should be true, right? That yes, eutectic point is the lowest temperature at which the liquid starts to turn into a solid. Next question. Non-equilibrium solidification of liquid metal leads to cored structure, right? So definitely right, if you know this part, then definitely true, isn't it? Because if it is equilibrium cooling, then there is a homogeneous structure everywhere. If it is a non-equilibrium cooling, which generally means faster cooling than equilibrium, then some cores are formed in some places and it is a cored structure. Okay. One more. After the process of homogenization, cored structure is formed in metals and alloys. So I have already showed you the answer by mistake, but yes, you see, after the process of homogenization, all the cored structure goes away, isn't it? Homogenization is the process, the heat treatment process, which is done so that the cores are removed and the material becomes homogenized again. So therefore this statement is false. After homogenization, the cored structure will not be there anymore. Okay, so these were some of the multiple choice and true false belonging to quiz 3. And of course this is the same for both the sections. Let us move on. Let's go to question 2a for section 10. Now the question is, briefly explain what is cored structure in alloys and how it can be removed. So rather than discussing it, let me just share with you the answer directly, right? Non-equilibrium solidification is carried out at a faster than normal cooling rate, resulting in a cored structure or a non-homogeneous structure. Cored structure can be removed by a heat treatment process called homogenization. So, right, I mean, if you know it, it is very good. If you did not, then it was very much there. So just let me also share with you, right, this portion of the slide. So this was the portion that non-equilibrium solidification of alloys. Non-equilibrium solidification, very slow cooling gives rise to cored structure, which is the equilibrium cooling. Rapid cooling delays solidification, rapid cooling, and therefore cores are formed inside this structure. This is a cored structure. And if there is a cored structure, then homogenization is a process which will remove the cores. So this should have been answered by everybody, inshallah, but I mean, this is the answer. Moving on, this is the question 2b for section 10. Consider the binary eutectic phase diagram shown in the figure. The figure is given. Make phase analyses of an 80 weight % silver, 20 weight % copper alloy at the temperatures of 900 Celsius and 780 Celsius minus delta T, which means just below 780. This is just for your explanation. Otherwise, if I had stopped here, make phase analyses, then you automatically know that it should include what are the phases present, what are the chemical compositions of the phases, what are the mass fractions of the phases, and what are the sketches of the microstructure of these phases, right? So I have written this here to explain the question, but if it was only the first sentence which finishes here, even then you would automatically know that I have to do these 4 things. When I say please do the phase analysis, then this is what you do. So now, I mean, you see, this is your diagram. I'll show you the diagram in a more enlarged manner. If you see, it is a copper silver alloy system and it is weight % silver. This is very important, that this is weight % silver. So if you were given 80 weight % silver, then you will draw a vertical line at 80. You will draw a vertical line at 80. If you were given a temperature of 900, you will draw a horizontal line at 900. And then if you are given a temperature of just below 780, so then this is your line. So there are two parts. First part is that this is your alloy, 80% silver. At 900 Celsius, what will be there? You see, this is purely in the liquid place. So it will be only liquid phase, right? The composition of the liquid phase will be the same as the original alloy, 88% silver. The mass fraction will be 100% liquid. Now go to part B of the question, 80 and 780 minus delta T. So you draw this tie line, On the left, it cuts alpha at 7.9 weight% silver. On the right, it cuts beta at 91.2 weight% silver. And in the middle, of course, is the 80%. So you draw the tie line and then you can give all of the answers, right? So when I go to the next page, please remember that this is how it is done, that you do the vertical line at the given composition of the alloy, and at the temperature of 900 and at the temperature of 780 minus delta T, you draw vertical horizontal lines, and then you do the question. So at 900 Celsius, phases only liquid, composition original alloy 88% silver, 28% copper, mass fraction 100% liquid, right, at 90. Then at 780 minus delta T, 780 minus delta T, remember the tie line. So on your left, right, so the answer, phases present are alpha and beta because it is just below. Composition of phases, for alpha you have 7.9 weight% silver, for beta you have 91.2 weight% silver. And if this is your tie line, on the left 7.9% silver alpha, on the right 91.2%, and in the middle 80 weight%. Then weight% of the alpha phase is, right, 91.2 minus 80, I have typed wrong, right, 80, not 88, 80, upon the total, and find the percentage. Weight% beta, right, on the opposite side, 80 minus 7.9 and so on. If I have done a wrong calculation, you can correct it, but it is 80 weight%, right, 80. If I have by mistake done it for 88, then this is wrong, right? It will be 91.2 minus 80 and so on, right? So this will be the you know that every time you just draw the tie line, and if you are finding alpha, which is on the left, then on the tie line do the lever rule for the right hand side, and when you are doing for beta, then do it for the left hand side. And if you have done it for alpha, for beta, don't do one minus the other, right? Do the actual calculation so that you know that if I add both of them, I will get 100. So this is the calculation. And now, because it is 80 weight%, it is on the right hand side, right? So on the top you have liquid, then you start to form beta, and when you go down, then you have alpha and beta, right? So my diagram here is slightly wrong, right? Slightly wrong, my mistake, because this thing is pro-eutectic beta. This thing is pro-eutectic beta, isn't it? Remember that above the tie line, the liquid changes to beta first, and once you hit the bottom line, then it all changes into alpha and beta. So this part is right, eutectic alpha and eutectic beta. This is right, but this is not pro-eutectic alpha, my mistake of typing and so on. This is pro-eutectic beta, right? So with that, we finish this portion, the general question on multiple choice and so on, and question 2A and 2B for section 10. We will continue solving inshallah further, but remember these are small mistakes that I have done, because I can also make mistakes, but we have corrected this here inshallah.